So I'm David Miller. I work at BBVA. I'm on the cloud governance and legacy migration team there. So this specifically is going to be the cloud governance side of things. So before I get started, give you a little bit about who I am. So I'm David Miller. I'm technical architect at BBVA. I went to Ole Miss for computer science, and I learned nothing about what I do day to day now. And I've got all three of my AWS Associate certifications. If that qualifies me as someone you should listen to, I don't know. I don't think so, but you know, I'm here, and they gave me a microphone, so let's go. All right. So the problem that we're talking about today is your organization has strict tagging requirements. I was just talking about, it's an issue they have here at Daxco with 23 accounts. We've got somewhere in the neighborhood, I think we've passed 100. Yeah, we're up to like 170 at BBVA. So it's managing anything at that scale with any kind of strict requirements and getting people to stay in line with it is kind of a challenge, and it's one that took us a while to kind of figure out a solution for. So secondly, those requirements have to be applied to new resources, but they also have to be enforced on all of your existing stuff, which presents a problem in and of itself because there are some solutions you can put in place that restrict people from creating new things that don't fit, but that doesn't necessarily solve the problem for all your old stuff. You also have no guarantee that your requirements are not going to change. So which tags have to be enforced, which tags are relevant to which resources, things of that nature could change over time. So you have to figure out a way to manage that in a way that can be updated without you having to redeploy to 170 accounts every time somebody decides to change the tags that are required. All right, so let's talk about some possible solutions for this. You can just trust your users to do it. Don't do that, ever. So second, you can do AWS service control policies. I think John has talked about those at one of these before, at least a little bit. So service control policies you can put in place to say, I don't want to allow any EC2 instances to be created that don't have all of these tags and have them populated. And that works great unless you're in a legacy account where you already have resources and your auto-scaling group doesn't have the tags it's supposed to, and now your service control policy stops your auto-scaling group from scaling up. Because then all your stuff breaks. So it can't just be service control policies. So what about AWS Config managed rules? So there are two types of rules in AWS Config. We've got managed that AWS makes, and then we've got custom where you can implement a Lambda or something to evaluate it yourself. And there is, in fact, a tagging requirements rule that AWS provides. So it's just one or two clicks in the console, it's set up, it's good to go. But the issue with it is it only allows up to 6 tags to be evaluated per rule. So in our instance, we have 16 tags that are part of our default set. So for us, we have to have 3 config rules put in place in order to evaluate all those if we're using the managed rule. And that means if we have those config rules set up to evaluate every time configuration changes on a resource, we get billed for 3 config evaluations every time a resource changes. And that can get very expensive very fast. So then what about custom config rules? So this is ultimately the route we took. We've built a custom solution that can check for required tags, and then there's no limit on it. We can have any number of tags. So right now, for most of our resources, we're checking for 16, and it's 1 config evaluation and 1 Lambda run that you have to run every time a config rule or every time configuration changes on a resource. So that winds up saving you money over the long term because you don't have all of these evaluations of config happening. But that is not the full solution, because that only fixes existing resources, and it doesn't shut your users down from continuing to create things that don't have tags from the get-go. So a combination of the custom rules and the service control policies is what really we've decided to implement to fix this problem both in our legacy accounts and our new accounts going forward. So the point that we're at right now, our service control policies are in place on all new accounts, so nothing new is being created. And the config roles are being rolled out to all of our old accounts. And now over time, we can ensure that everything in the old accounts is being created with the required tags, and then we can roll out the service control policies to those as well. But for now, we have the config rules to hold us in place. The other thing that the config rules give us that service control policies don't necessarily is if a resource exists and it fits the requirements, and then a user goes in and decides to delete a bunch of tags, what are you going to do about that? So config rules can identify that and then automatically remediate it if that takes place. So let's talk about the architecture that we've decided to go with for this, because it seems pretty straightforward. We have one DynamoDB table that lives in a centralized account, and it has a list for each resource type inside of it. So for RDS instances, these are the required tags that we have set for RDS instances. Every other account, when their config rules run, the Lambda assume roles into this account with the DynamoDB table, pulls the list out of there, and then evaluates against it. This solves the problem of your requirements changing. Because if your tags get updated, the only thing that you have to change to have it updated across all 170 accounts is put a new entry in the DynamoDB table. Everything reads from it, and it reads every time it runs. So there's nothing stored in each of the accounts that is used to determine which tags are required. Then we have two config rules. Now the reason we have two is because right now we're not automatically applying values when we remediate tags. We only apply the tag key, leave the value empty, and then we have a second rule that goes back through and says, hey, you're non-compliant with having values in all of your required tags. So that way we don't have users trying to come to us and saying, like, which tags are required on everything. They're already applied. All they have to do is go check the config rule, see which resources are non-compliant, and then go and fill out all of the empty values on their resource. So we have our first rule, which says, do the tags exist at all? And if they don't, run a remediation action to add those tags with no values. We have our second tool that says, our second rule that says, are they populated? And if not, mark it non-compliant, let your user who owns the account know, so that they can go in and fill that out. So this is what the first one looks like. And there are some odd choices here that I'm going to hopefully be able to explain sufficiently. So we have a separate rule for each resource type. And the reason for that is because as you walk through our architecture, we've got our rule that triggers the Lambda that checks to see if it's compliant, which references the DynamoDB table, then returns to the rule and says whether or not the thing is compliant, and if it's not, publish to SNS. Now, why are we publishing to SNS and not just triggering the Lambda that's going to remediate it? The way AWS Config is designed, when you want to do a remediation action, the only options that you have are SSM automation documents. And for some reason, at this point in time, or at least when we designed this, this may have updated since then, there was no SSM automation document that says trigger a Lambda function. There's one that publishes to an SNS topic, but if we publish to an SNS topic, we run into an issue of only being able to include the resource ID in our message, which seems like it's all you need, except if I tell you that your Lambda needs to be able to accept or to remediate any type of resource, and all I'm going to give you is the ID. So for an EC2 instance, that may be I dash number, or for an S3 bucket, it may be the whole ARN or the whole name, or for an RDS instance, it's just going to be DB dash whatever. When your Lambda goes to look at that, it has no idea of when it looks at it, it has no way to like build out the ARN and then go and run tagging against it, because it doesn't know which service that ID belongs to, which is why we have it split out into 3 separate rules. Each of these SNS topics have a name that is built in such a way that it identifies which type of resource the relevant, or which type of resources that topic is relevant to. So for the EC2 tags present rule, it's going to push to a topic that has EC2 instance in the name. So it pushes that notification out to the EC2 specific topic, and then all of those are subscribed to by a single SQS queue. Them going to that queue means when we point a Lambda at the queue, we can see both the message that was in the original notification as well as which topic it came from. We can do a little bit of logic on the name of the topic it came from, figure out which resource type it is, build out the yarn, and then we're able to apply tags. So the aggregator queue takes it from everything, and this can expand out to as many resource types as you want. And then the queue is what triggers our remediation Lambda, which then goes out and applies whatever tags were missing that caused the rule to be marked as non-compliant. So that's our first rule and its remediation. And then our second rule is very, very simple. It's just our value validation rule. It runs a Lambda that says, hey, is there, right now it just checks to see if the value is empty. So it goes out to each of the, or it goes out to the DynamoDB table, says these are all the relevant tags for this resource, checks that on the resource that it's evaluating and says if this is empty, or if any of these are empty, mark it non-compliant, send that back to config so it can be marked there so that the user can fix it. All right, so let's look at this in action. I'm going to hop into system preferences. And I need to mirror these. Okay, so right now I have everything built out as a CloudFormation stack, which I'm just going to gloss over because it's going to be really boring to go through all this code. But this just builds out everything we just walked through, with the exception of the DynamoDB table, which is built out by a second stack. So this is the DynamoDB table. It's already up, already exists, and you can hop in here and see it's got, so right now it's got a default if the issue type doesn't already exist, or it hasn't already been added to the DynamoDB table, it'll just go to the default and say, apply these 7 tags, or check for these 7 tags. If it does have specific extra tags it needs to look for, so for an RDS instance, maybe it needs to know what database engine it's running on, it'll instead go to the specific item for its resource type. So all of the CloudFormation all the CloudFormation is just hanging out in an S3 bucket as well as the Python code for all the Lambdas. So if we hop in here, whoop, I need to grab that URL first. We hop into CloudFormation. And gloss over all this stuff. I'm just going to run it with my own credentials, which is admin in this account. If you were doing this in an enterprise environment, you'd give the CloudFormation stack its own permissions to be able to run without using your own user. All right, so this is going to run and should just take just a minute. Do we have any questions now? We can answer that while this is running. Or we can just kind of stand awkwardly in silence. So, you have jumped ahead to my V2 improvements. Number 3 is combine the lambdas. So this was kind of put together in a pretty quick fashion. That is the next step is we're planning on adding specific values that are valid for each tag for it to check for, as well as default values that it can populate with instead of just empty values, and then combining the lambdas so we can just include a flag that says, do you need to check if it's empty or do you need to check if it's present? What's that? Because if the Lambda fails for whatever reason, if we're doing it as a topic, that message will have already been pulled off and it'll be lost. So it won't be remediated. If it's in the queue and the Lambda fails, then it'll just pop back in the queue and the Lambda can pick it. Another iteration of the Lambda can pick it up and retry.
So you're not running your config rules, you're only running your config rules on changes, or are you doing periodic runs?
Right now we're running on changes only, because if we do it on a schedule, yeah, it's a lot of resources. So across 170 accounts, if we do it on a schedule every 12 hours, we've got, oh yeah, they would, our management would not. So on changes is very expensive at deployment time, but then after that, it kind of cuts the cost down because you're only doing it every time something changes. And once an account is set up and has all of its infrastructure running and its application built out, there's not a whole lot of those changes going on. I don't believe we did.
I don't know if the performance improvement was
Yeah. No, but that may be something I should add to my V2 improvement slide. All right, so this stack is built out now. So we've got all of our stuff going. And what I didn't show you before this is, okay, this bucket, actually both buckets in this account, didn't have any tags, I promise. Since that has built out, it has created so I already had an EC2 instance up that had no tags on it. I had an RDS instance up with no tags on it. I had a couple S3 buckets. So if we hop into config now, you'll see we've got a required tags rule for each of our resource types. And then we've got the value validation one that runs on all resource types just to check if the tags are populated. So this is going to say they're non-compliant because the way that we have architected the lambdas, they are not actually looking at the resource API itself. They're looking at the, if you go into resource groups in the console, there's a subsection called tag editors. It's not particularly well documented. It's a whole other API that's not really related to resource groups. But what it gives you is essentially service agnostic tagging API. So instead of us having to build out specific code to tag our EC2s and specific code to tag out our S3 buckets, we hit the tagging API instead, and it's one set of code for all resource types. That tagging API is how we set it up to be generic, and then we're also looking at, on the evaluation side, the configuration item coming from AWS Config, not the resource itself, because it gives us an agnostic way to evaluate the resource. The only issue with that is that it occasionally takes a minute or two to pick up that configuration has actually changed and update in AWS Config to then know that it needs to reevaluate and determine that a resource is now compliant. So these are still saying they're non-compliant, but if we reevaluate, it's probably still going to say they're non-compliant because this items configuration timeline hasn't been updated yet. Right, so you can see last night I was testing things, and then this is the current configuration item for this bucket. Once config picks up that this has changed, it'll trigger a new evaluation, and the rule will be updated to say that it's compliant, and the value validation rule will start failing because the tags are all empty. And we can go in and see, I haven't refreshed yet, so there's no tags on it. And all of my tags are now on my EC2 instance and RDS and S3 buckets.
How are you going to notify downstream non-compliant folks to get when it's accounts?
Right, so we have one of the tags actually that we're applying at everything is who like technical owners and line of business owners are, and so we have that tagged at an account level as well, and then we have aggregators running, so we can go through and aggregate and say everything in this account, aggregate, tell me like what all resources that are non-compliant, and then notify whoever's in that tag at the account level. We haven't rolled that out yet, but that is the plan. Alternatively, if they hop into the config console, they'll see everything that's non-compliant and can go from there.
Can you guys talk about triggering the cloud watch alarm?
Sorry?
Maybe triggering the cloud watch alarm?
We'll probably do something along CloudWatch or an SNS topic. We haven't built it out yet, so I don't, right now we've got it here and we can aggregate it all in our master billing account where we can see what it looks like across all of our resources. So that's kind of the demo. This can take anywhere from like 30 seconds to like 15 minutes for this to update, so we're not going to stare at that for too long. We've already jumped ahead. We've done our V2 improvement slide. There are some inefficiencies in it that will be improved in the next version. And then, are there any other questions? Thanks for having me, I guess. This is my first one and will be my last one. I'm moving away in a couple weeks, but appreciate the chance to come out.
What do you like best about tagging?
About tagging? Nothing. I don't like, I really, personally, no. Organizationally, it gives us a lot of benefits because we can, assign, the biggest thing we're doing right now is I'm on the cloud governance and legacy migration team. We're going into all of our legacy accounts and tagging those with stuff like Cost Center. As we move that out of legacy accounts into our new environment, we can track cost changes based on that Cost Center tag in the old account into the new account. And so we can show for our team like what value we're giving as we're right-sizing things and saying like this was built way too large last time, now we're costing a quarter of what it was then and it still runs just as good. So that's, I don't like it, but it does give us some benefits. Anybody else?
Are any of your lambdas available like in our public repo or anything?
Could they be? They could be. I can put them up in a GitHub repo after this and send you a link to send out to everybody. I can actually put up the whole stack and everything. I took out all the proprietary stuff last night.